Okay, let's continue our topic. Okay, say we have a new project, space, steel design, steel structure. Okay, tapos BMUF's location is in Staad, computer Staad. Okay, yan. Tapos, yan. Next, then finish. Okay, so okay, ayan. So that will be our screen. Then close natin. Then 0. Type here 0. Then just go to geometry. Click nyo lang yan. And that's our 0, point. So select node natin yan. Then Control C, Control V. Yan na natin yan. 4.5 meters sa Z. So ano na lang natin siya. Translation na repeat sa Z. That is sabihin tig 4.5 meters. Naulitin ko yan ng isa, dalawa, tatlo. Okay. Then click OK. Yan. Tapos select natin yan. Tapos i-translational repeat natin sa Y. Then yan natin siya na 3.2 meters. Okay, 3.2 meters. Isa lang link steps natin. So pataas na siya, Shift E. So starting point, end point. Okay. Then ang gagawin natin dyan is gawa tayo dito ng add beams. Add beams tayo. Ayan. Okay. Tapos select natin itong mga beams natin. Let us select the beams. Okay, let us select the beams. And then translational repeat. Tapos sa X, yan natin 6 meters. Okay, ulitin natin ng 3 beses. 6 meters, then number of steps 3, then link steps, then click OK. Okay. Tapos select natin itong gamit tayo ng beam cursor. Select natin itong mga beams. Tapos translational repeat natin. Then ulitin natin siya sa may X direction. So that is gayating 6 meters. Then tatlo din. Huwag natin i-link steps. Okay, then click OK. Then after modeling, okay, so say dito, maglalagay ako ng brace. Okay, then gagawa ko ng brace. So I will select add beams. Ilalagay ko dito tapos sa gitna. Okay, pero hindi ako makapaglagay kasi there's no node. Walang node sa gitna. So ang gagawin ko dyan is insert node. Ayan, click natin yung beam, then insert node. So, sa gitna ako maglalagay ng brace. Just simply add midpoint, then click OK. So, meron na tayong node sa gitna. And gusto ko maglagay dyan ng brace. So, lagay ko dyan is add beams. So, may brace dyan, tapos may isa pang brace. Okay. Tapos, dito, gusto ko maglagay ng, this is the vertical brace for the steel design. Ngayon gusto ko maglagay ng horizontal na na brace. Okay? So, pwede natin gawin dyan is ganito. Insert node, midpoint. Tapos insert node din dito, midpoint din. Ayan. Then, Nilagay ako ng horizontal brace. Okay, so ayan siya. Questions will be entertained later after the discussion. Okay, so ayan siya guys. That is the horizontal brace. Ito. Tapos this is the vertical brace. Okay. Now, anong next dyan, sir? After ng geometry, we'll go to the generals. Okay, they will go to the generals. Okay. So, general is, magde-define tayo dyan ng section database. Now, this is already the steel design. So, we're going to make a section database. Before, sa reinforced concrete design is defined. But now in steel design, we are going to make section database. So, for the section database, okay, so gamit tayo dyan ng European. Okay, for the wide flange sections, or sa ano tayo, sa Japanese. Pwede tayong gumamit ng Japanese. So, H-shape. Gumamit tayo ng H-shape. That H-shape is also the wide flange. So, pwede tayong gumamit dito. Ayan yung mga sections natin. So, nakalagay yung depth. Okay, BF, TF, thickness ng flange, thickness ng web, tsaka yung moments of the inertia natin. So, gamit tayo ng, say, 175 by 90 para sa columns. Select. Then, add natin. Okay, nadagdag na siya doon. Then, para sa beams naman, is gamit tayo sa beams ng H-shape din pero medyo mas maliit. Say 150 or kahit 125 lang. Okay. Then, nadagdag na siya. Then, for the brace naman, gamit lang tayo ng angle na 50 by 50 by 4. Okay, or kahit si 75 by 75 by 6. Then, dagdag natin yan dyan. Double click natin. Kung single angle lang, isa. Kung double angle, wherein long leg niya is back to back. Okay, say dito, double angle, long leg, back to back. So, ganito yung itsura ng double angle natin. Okay, na long leg, back to back. Yan, ganyan siya. Okay. So, balik tayo sa Staad. So, dito tayo. 75 by 75 by 6 na dagdag na dito. Okay. So, since tapos na tayo dito sa general, dito sa property, i-assign na natin itong mga to. Okay. So, ito, as I said, this 175 should be applied for the columns. So, click nyo yan. Then, select beams parallel to Y. Okay. Then, assign to selected beams. Then, assign. Yes. Next one. Okay. For the beams, okay, this one is i-assign natin siya. Select beams parallel to Y. Oops. Select natin to. Select beams parallel to X. Select beams parallel to Z. Then select assign to selected beams. Assign. Click yes. Okay. Then for the brace, okay, for the brace, is ang gagawin natin dyan is since konti lang naman siya, we'll just click these braces. Okay, this horizontal and the vertical braces. Then assign to selected beams. Assign. So we already assigned the materials. Now, we'll go to the specs. Okay, for the specifications. Okay, so dyan, that's the time that we're going to make releases. Okay, so on our first discussion, the reinforced concrete design, if a member is not carrying moment, then we are going to release that. However, if we want to carry it a moment, then even just a small portion. So we can create a 99% release wherein 1% moment is being carried by a member. So ang i-release natin dyan is itong mga braces. Okay? Because these braces will only carry axial forces, but in reality, it will still carry moment. So let's just release 99% and let that 1% moment be carried by the members. Okay? Here in the perimeters, as said by Sir, the girders, these are the girders. Okay? Itong mga nasa perimeters natin. So, they are moment connections. Okay? So, may mga moments yan na kinikerry. Okay, so it's up to you as a structural designer if magre-release tayo dito sa ibang parts. Say naglagay ako ng horizontal member dito. So mag-insert ako dyan ng node, insert node, tapos add midpoint, then click OK. Okay, so we have already a nodes there. So just add beams. Ayan. So this one, this is an added brace. So let's create the specifications para sa releases. Within beam, release, partial moment release, moment Y, and then the moment Z. For the moment Y, just release the moment Y, moment about Y for 99% and let 1% be carried by the member, then 0.99 also here. So that is for the start node. And click add. Next one is for the beam partial moment release, moment at Z, then MPY, MPZ, so 0.99, then another 0.99. Okay, so click add. Then, okay, click natin yung mga members na pag-aasahin natin ng release. So, assign to selected beams, assign. Then, it should be N. Delete natin to. This is already the start, so we should create the N. Partial moment release, MPY, click MPZ, then 0.99, 0.99. Click add, then naka-select pa rin siya yung mga members natin. Select natin. Let us select the members to specify the releases. So assign to selected beams, assign, click yes. So ayan na siya. Now next is after assigning the specs, let us assign the supports. Okay, so for the support, let's create. So it's either fixed or plain or fixed but. So for this one, gamitin natin is plain support. Click add. Depende sa inyo guys kung pin support or fixed support. Okay, so depende sa specification ng project kung sobrang lakas ng lateral force. If the lateral force is so extreme, then we could decide to make it in moment support. But if it is a moment support, our foundation will get bigger because it will carry moment. However, if it is pin support, the foundation will get small but the members will get large. So babalansin natin kung mataas pa yung capacity ng members, if the capacity of the members still large, then we could make it a pin support. However, if we have a limited sizes, okay, then we could transfer those forces to the foundation. Okay, so gawin natin is gawin natin siyang sige, moment support na lang, no? So create tayo, fix support, add. So, ayan siya. Uy, dalawa na yung support. Isang pin. So, isang fix. Delete natin yung pin. I-retain natin yung fix. So, let us go to front view, which is Z. Okay, so we will view from the positive Z. Okay, so we will look from here, looking there. Okay, so Z. Then using the node cursor, we will select all of these nodes. Then let's go to isometric. So na-select na yung mga nodes na para sa support. Then just click Alt V V. Okay. Then for the supports, click this one. Then Control A. Tapos assign to selected nodes, assign. Click yes. Tapos you will go to full structure. Ayan. Okay. So that is already the full structure natin. Okay. Next one is the load and definition. For the load and definitions, okay, so there's a different applications for the load, like concentrated load and the pressure loads. Mga ganun, no? So, for this one, okay, so i-load lang muna natin sa concentrated loads. Okay, concentrated loads. Same, maglo-load ako ng force dito along the lengths. Okay, so dito tayo sa load cases, then click add dead. For the dead load, DL, add L. For the live load, okay, pero wag muna natin lagyan ng live load. Sige, ang ilagay lang natin na live load natin is LL. Sige, ilagay natin na LL. So dead load, click add self weight. So i-add natin yung self weight, click add. Then for the self weight, apply natin siya sa buong structure. For self weight, assign to view, click assign, click yes. Okay, so therefore the dead load self weight for this structure is already assigned. Next one, for the live load. Depende itong live load. Pwede kayong magdagdag ng iba't ibang klaseng loads. Seismic, snow, fluid loads, soil, mga ganun, no? Sige, dagdag tayo ng fluid loads or pipe loads. May pipe loads pa dito. Wala. So, sige, fluid na lang. FN, fluid loads. So, natin may pipe dito na nakalatag sa taas. Okay. So, tanggalin natin itong dead load. Say, we have a fluid loads. And those loads are acting horizontally sa member natin. Okay. So, nakalatag yung buong pipe dito sa taas. So, since that is okay, this is the starting point, this is the end point, we will apply the loads at the midspan. Okay, depende kung saan naka-load exactly yung forces natin. So, say mag-a-apply ako dyan ng load na I will apply a horizontal load, which is a member load. Okay, say concentrated force, which is that is a negative, say 2 kilonewton. Okay, distance 1 from the first point. Okay, so global Y, global X, global Z. So I want this to be in global X direction. Add, then close. So ano bang length nito? Okay, the length niyan is 4.5. So kalahati ng 4.5, that is 1/2 of 4.5 is 2.25. Therefore, this 2 kilonewton, i-apply ko siya dito. So i-edit ko siya. The distance 1 from the starting point, okay, the distance 1 should be 2.25. So 2.25. Then click. Change, then okay. So assign natin siya dito. Ito. Assign to selected beams. Assign, click yes. So yun na yung force natin. Then just right click on the space. Then we could see the labels. Then for the forces, for the load values, just click this one. Or simply shift V. Okay? Then makita na natin itong 2 kN. Shift V lang guys. Okay? So, ayun na siya. 2 kN natin. Then, apply another 2 kN here, dito, tsaka dito. So, pwede natin siyang i-call out tong mga members na to. New view. Click OK. Then, Shift B natin. Tapos, dito, type na lang natin yung mga members na pag-apply natin. Member 27, 52, 20, ayaw. 57, ayaw matype pa. Yan na lang. Click natin to. Then, assign to view. Assign, click yes. Okay, so na-apply na yung tig 2 kN sa bawat member. Okay, so click natin to. So, meron na tayong forces dyan. Okay, so paano mag-compute ng forcer? Okay, yung paano mag-compute naman ng force given ay pressure. Okay, so ganito yan. We have a Excel spreadsheet here. Tapos, sige, say we have a pressure or applied pressure na 2 kilopascal. We have applied pressure of 2 kilopascal. So, para maging uniformly distributed load yan, mumultiply natin yung P na yan sa tributary width. Okay, mumultiply natin yan sa tributary width para maging uniform load, which is ang unit na nito is in kilonewton per meter. Okay, so, tapos para maging force naman yan, i-multiply natin yan doon sa thickness. So, say this one. Okay, so select natin siya, right click, structure diagrams, then we have a full sections outline, apply. Okay, structure diagrams, full sections, apply. Okay, yan, say yan yung sections natin. Say yan yung sections natin. Okay, so kung may pressure tayo, multiply lang natin doon sa specified na tributary width natin. So magiging line load na siya. Ngayon, para ma-apply siya dito as concentrated load, multiply lang natin siya sa thickness ng flange. Okay? Say this one, this has a flange property. Yung flange niya is 0.125. Okay? So say we have a pressure of, say yung pressure natin is 2 kilopascal. Ngayon, we have a tributary width. Sabi natin yung tributary width natin is 1 meter or kahit 1.5 meters. Okay, 1.5 meters. So, yan yung tributary width natin. So, width. Therefore, to make it a uniform uniformly distributed load, that would be the pressure multiplied by the tributary wind. Okay, so that will now be in kilonewton per meter. Now to make it force concentrated load, therefore we'll just going to multiply this one sa flange width natin. This is the flange width, wherein our flange width is ilan ito? So property of 0.125 meters. Okay, so that is flange width equals 0.125 meters. Okay, so therefore our concentrated load will now be uniformly distributed load multiplied by 0.125 meters. That will now be in kilonewton. Therefore, for this part, sabi natin may mga pipes dyan or may pressure tayong gustong i-apply. Sabi natin ditong part na to. Okay? So, sabi natin sa beam na to, let us say that this is the beam. Okay, that is the beam. And we have series of pipes here. And that is 1 meter yan. Okay, meron diyang mga pipes. There are a series of pipes. And as per actual job, this series of pipes, if less than 4 inches their diameter, it is applied as pressure. Okay, it is applied as pressure. Sabi natin 2 kilopascal yan. Okay, 2 kilopascal. At ang haba niyan is, ang haba nitong part na to is 1 meter or 1.5 meters. Okay, and this one, that is the beam. Okay, itong beam na to guys is ito. Okay, either yan or ito, depende. Pero dito na lang natin i-apply sa beam na yan. So we have 2 kilopascal and we want to apply it here. Okay, so insert shapes. So we have length here. Ikapalan natin yan. And we have also length here, which is, this is the width of the flange, which is that width of the flange is, that width of the flange is 125 mm. Ayan. But it should be in the shape of that one if we made the cross section is like this one. Okay, ganyan siya guys. Okay, so ito siya. Now, this 2 kilopascal will be multiplied to 1.5 meters to make it as uniformly distributed load. Okay, so gagawin natin siyang uniformly distributed loads. Okay, we will make it in uniformly distributed loads. So, ganyan siya. Okay, I hope you can still visualize it, and that uniformly distributed load is now already in, ilan na siya? 3 kilonewton per meter. 3 kilonewton per meter. Now, we want this uniformly distributed load. Okay, this 2 kilopascal na in-apply here should be 2 kilopascal multiplied by the flange width. Multiplied by the flange width dapat siya. Okay. Then, flange width 0.125. Ito. So, yung uniformly distributed load natin, it should be multiplied by 0.125 meters. Okay, that is 0.25. 0.25. So, yung pressure dapat i-multiply natin sa flange width para maging uniformly distributed load siya. Now, para maging concentrated load siya, okay, kung gusto natin siyang, if we want it to make concentrated load, then, if we want it to make in concentrated load, so, kapalan natin to. If we want to make it in concentrated load, we'll just multiply this W dito sa 1.5 meters. Okay. So, the concentrated load now will be yung uniformly distributed load multiplied sa length na 1.5 meters. So, that will be 0.375 kilonewton. So, this will be 0.375 kilonewton per meter. Kilonewton meter. So, mas maganda dyan i-apply natin siya as uniformly distributed load. Okay? So, ano bang length ng beam natin dito? This is having a length of 4.5 meters pag dinouble click natin. So, therefore, magdadagdag tayo dito sa fluid loads. Then, dagdag tayo. Click natin to. Then, click add. Then, physical member load. Then, this one. Ilan yung na-compute natin? That is na-compute natin 0.25 kilonewton per meter. That is negative 0.25. It is at global Y. Then, i-edit na lang natin to mamaya. Click add. Close. Then, here, since this length, ang haba niyan is, ganyang haba niya, that is 4.5 meters. Since yung haba niya is 4.5 meters, therefore, the starting point of the uniformly distributed load is located at a distance 4.5 minus 1.5 divided by 2. So that would be 4.5 minus 1.5 divided by 2. That would be 1.5 mula dito. Okay? So, yung loads is mula sa starting point, 1.5. Then, add another 1.5, tapos 1.5 naman na dun sa dulo. Therefore, dito sa load natin na 0.25 kN per meter, edit natin yun. Yung D1 is the distance of the starting point of the load from the starting point of the beam. Okay, so that is 1.5. Then for the D2 is the location of the endpoint of the load from the starting point of the beam. So that is 3. Click change, close. So apply natin to dito sa mga beams natin. So click natin ito mga to, beams natin, tsaka ito. So apply natin dyan itong 0.25. 0.25 kN per meter. Assign to selected beams. Click natin to. Then assign. Click yes. So we'll now have na-convert siya sa pounds per inch. Which is dapat ay naka-kilonewton per meter siya. So format view management, view options, load labels, kilonewton, force units, distributed force should be in kilonewton per meter. The moment, kilonewton meter, distributed moment, kilonewton meter per meter, megapascal, meters per second, meters per second squared. Then apply, click OK. Yan, naka-kilonewton per meter na tayo. Okay, so yan yung mga loads natin. So, ayan, kitang-kita, no? We have uniform load here. Tapos meron tayong horizontal loads. Now, after applying loads, let's add load combination. Okay, see yung load combination natin, load generation. Ito, our load combination, say load case 1. Okay, but this load combination can be viewed in the DSCE. Okay, so load case 1, add natin doon say 1.2, tapos 1.6 naman yung isa. Click add, close. Okay, so next one, after applying, then click materials, tapos analysis print, perform analysis, just simply click add, then close. Okay, then sa design, let's use EISC LRFT. AISC LFD. Then assign to view. Yan yung design po na gagamitin natin. For the steel design, okay, for the modeling of steel structures, see in this part. So guys, makinig ng maigi. New view natin. Then click OK. For this part, okay, we need to define the LR at KLY, KLZ. Ganun, no? So we need to define the KY, KZ. So say this part. So structure diagrams, full sections, apply. Ayan. This is our structure. Okay, this is our structure. Now, okay, there's only remaining 1 minute. Okay, so kindly enter again. Let's continue the discussion.